At first glance, it does not look like an airplane. It looks like a helicopter cockpit, a surveillance drone, and a science fiction machine, all fused into one strange aircraft. A giant glass bubble sits at the front. Behind it, a hidden ducted fan pushes the aircraft forward. Two tail booms stretch backward. The wings look simple. The landing gear is fixed. And from certain angles, the whole aircraft looks less like a plane and more like a flying eyeball. This is the Edgley Optica, one of the strangest aircraft ever built. It was not designed to be fast. It was not designed to be beautiful. It was not designed to win air races. It was designed to do one thing extremely well. Watch. The Optica was created as a cheaper, quieter alternative to helicopters for surveillance, police patrol, search and rescue, aerial photography, pipeline inspection, and low-speed observation. On paper, the idea made sense. It could fly slowly. It gave the crew an incredible view. It cost less to operate than a helicopter, and it looked like it had been designed for the future. So why did it fail? Why did an aircraft this clever almost disappear? And why do aviation fans still believe the Edgley Optica may have arrived too early? Let's break down the story of the strange plane built to replace helicopters. Helicopters are some of the most useful aircraft in the world. They can hover. They can take off vertically. They can land almost anywhere. That makes them perfect for police work, rescue missions, traffic patrol, border surveillance, filming, and emergency response. But helicopters have one major problem. They are expensive. Expensive to buy, expensive to fly, expensive to maintain, and mechanically complicated. The rotor system, gearbox, transmission, tail rotor, vibration, and maintenance requirements make helicopters costly machines to operate. For some missions, that cost is worth it. If you need to land on a rooftop, rescue someone from a mountain, or hover in place, you need a helicopter. But many observation missions do not actually need hovering. A police department watching traffic may only need a stable aircraft with a great view. A utility company inspecting power lines may only need slow flight and visibility. A search team scanning a coastline may not need vertical landing. They just need eyes in the sky. That was the gap John Edgley saw. He realized that a normal airplane was cheaper than a helicopter, but it did not offer the same view. A helicopter had the view, but it was expensive. So the question became, could someone build an aircraft with helicopter-like visibility, but fixed-wing efficiency? That question created the Edgley Optica. John Edgley did not design the Optica like a normal airplane. He designed it around the observer. Most small aircraft have the engine in front, a narrow cockpit, wings blocking parts of the view, and a fuselage that limits downward visibility. For observation work, that is a problem. If you are looking for a missing person, watching traffic, photographing terrain, or inspecting a pipeline, the aircraft's view is everything. So Edgley started with visibility. He placed the crew inside a large glass cockpit at the very front of the aircraft. Then he moved the engine behind the cabin. That meant nothing blocked the forward view. No long nose. No propeller disc in front of the pilot. No engine cowling hiding the ground below. The result was a cabin that looked more like a helicopter than an airplane. The Optica had 3 seats, 1 pilot and 2 observers or passengers. They sat inside a wide, rounded, almost panoramic cockpit. This gave the crew a field of view often described as around 270 degrees. From inside, the aircraft made sense. From outside, it looked bizarre. But that strange shape was not a mistake. It was the whole point. The Optica was not designed to look normal. It was designed to see better. And that is why people still remember it. The Optica's cockpit is its most famous feature. It is also the reason people either love it or laugh at it. The giant glass nose makes the aircraft look like a flying eyeball. But for surveillance and observation, that cockpit was brilliant. The pilot and observers could look forward, sideways, and downward much more easily than in a conventional small airplane. That made the aircraft useful for missions where the crew needed to keep eyes on the ground. Police patrol, search and rescue, wildlife monitoring, aerial photography, coastal patrol, environmental survey, pipeline inspection. The Optica was basically an airborne observation platform. It was not trying to be glamorous. It was trying to be useful. A Cessna or Piper could perform observation work, but those aircraft were not designed around the view. The Optica was. That is what made it different. It was a fixed-wing aircraft built with a helicopter-style perspective, and for many missions, that seemed like the perfect compromise. The view was not just a feature. It was the aircraft's identity. The Optica was built around human vision. That is why it still feels modern today. Because in modern aviation, sensors, cameras, and observation systems matter more than ever. The Optica understood that decades ago. It was not built to fly fast. It was built to see. The second strange feature of the Optica was its propulsion system. Instead of a normal front-mounted propeller, the aircraft used a rear-mounted ducted fan. The engine sat behind the cockpit and drove a fan inside a circular duct. This made the aircraft look even more unusual. But again, there was a reason. A front propeller would have blocked the view from the cabin. That would have destroyed the aircraft's biggest advantage. So Edgley moved the propulsion system behind the crew. The ducted fan also helped reduce noise compared with many conventional aircraft and helicopters. That mattered because the Optica was designed for low-speed observation. An aircraft used for police patrol or surveillance might fly over neighborhoods, roads, coastlines, or public areas. A loud helicopter can attract attention immediately. It can disturb people on the ground. It can be expensive and intrusive. The Optica promised something quieter and less aggressive. It could fly slowly over an area without sounding like a helicopter beating the air apart. That made it attractive for surveillance missions. The ducted fan was not just a technical gimmick. It protected the view. It supported the mission. And it helped make the aircraft different from anything else in the sky. The Optica's design may have looked strange, but almost every strange feature had a purpose. Most airplanes are sold with speed. Fast cruise speed, high performance, long range, powerful engines. But the Optica was different. It was built to fly slowly. For a normal aircraft, that might sound like a weakness. For the Optica, it was the mission. If you are watching a road, inspecting a pipeline, filming a landscape, or searching for someone on the ground, speed is not always helpful. You do not want to rush past the target. You want time. Time to look. Time to photograph. Time to circle. Time to understand what is happening below. The Optica was designed for that kind of flying. It could cruise slowly and give its crew an excellent view. It was not a helicopter, so it could not hover. But it could loiter. And for many observation jobs, loitering was enough. This made it a possible middle ground between a helicopter and a light airplane. A helicopter could hover, but it was expensive. A normal airplane was cheaper, but visibility was limited. The Optica tried to combine the best parts of both: fixed-wing efficiency, helicopter-like visibility, lower noise, lower operating cost, and a cabin built for observation. That is why the aircraft made so much sense on paper. It did not need to be the fastest plane. It needed to be the best flying observation deck. When the Optica first flew in 1979, It looked like something from the future. Most light aircraft of that era followed familiar shapes. A nose engine, a normal fuselage, a traditional tail, a cockpit behind the propeller. The Optica broke that pattern completely. Its glass bubble cockpit made it look like a helicopter. Its wings made it a fixed-wing aircraft. Its ducted fan made it look experimental. Its twin-tail booms gave it a strange futuristic silhouette. People noticed it instantly. That visual identity was both a blessing and a curse. On one hand, the Optica was unforgettable. It did not look like anything else. That helped it gain attention. On the other hand, aviation buyers can be conservative. Police agencies, government operators, and commercial customers usually want proven aircraft. They want easy maintenance, reliable parts support, known performance, pilot familiarity, insurance confidence, and a manufacturer that will still exist years later. The Optica had to prove not only that it could fly, but that its strange design was practical. That is hard for any new aircraft. It is even harder when the aircraft looks like a flying science experiment. Still, the early signs were promising. The Optica was not just a sketch. It flew. It entered production. And it eventually received certification. For a moment, it looked like this strange aircraft might actually create a new category. Then, everything started to go wrong. In 1985, the Optica suffered a tragedy that changed its future. One aircraft crashed during a police-related operation, killing the pilot and photographer on board. For any aircraft, a fatal accident is serious. But for a new aircraft trying to earn trust, it can be devastating. The Optica was already unusual. It already needed buyers to believe in something different. After the crash, that became much harder. Even when investigations do not prove that an aircraft is fundamentally unsafe, public perception can still shift. Operators become cautious. Agencies hesitate. Insurance becomes more difficult. The media narrative changes. And for a specialized aircraft aimed at police and government customers, reputation is everything. The Optica needed confidence. Instead, it received doubt. That accident did not destroy the aircraft by itself, but it weakened the business at a critical moment. The Optica was still trying to prove that it could be a serious alternative to helicopters for certain missions. Now it had to prove something even harder, that it could be trusted. And then came another disaster, one that had nothing to do with flying. After the crash damaged confidence, the Optica faced another major setback. A factory fire destroyed aircraft and disrupted production. For a large aerospace company, a disaster like this would be painful. For a small manufacturer, it can be fatal. The Optica did not have the deep financial resources of a giant aircraft company. It needed every order, every customer, every airframe, every part. When production aircraft and facilities were damaged, the entire future of the project became uncertain. The timing was terrible. The aircraft already had to fight for market acceptance. It already looked unusual. It had already suffered a fatal accident. Now the production base itself was damaged. This is how many promising aviation projects disappear. Not because the idea is useless. Not because the aircraft cannot fly. But because the business cannot survive long enough for the market to accept it. The Optica went through ownership changes, financial problems, and production interruptions. Only a small number were built. What could have become a new category of observation aircraft became a rare aviation curiosity. But the story did not end there. Because the idea behind the Optica never really stopped making sense. In fact, decades later, it may look smarter than ever. The Edgley Optica may have failed commercially, but its core idea aged well. Today, aerial observation is more important than ever. Police departments use aircraft and drones. Border agencies use surveillance platforms. Utility companies inspect power lines and pipelines. Environmental teams monitor forests, wildlife, and coastlines. Search and rescue crews need fast aerial visibility. Film crews need smooth, slow aerial shots. And drones have made everyone understand the value of seeing from above. In that world, the Optica feels surprisingly modern. It was built around visibility. It was designed to be quieter than a helicopter. It focused on low-speed observation. It offered fixed-wing efficiency. It tried to reduce the cost of missions that helicopters often performed. That sounds very much like the aviation world we live in now. The difference is that drones arrived later and took over many low-cost observation roles. Unmanned aircraft can do dangerous or repetitive missions without risking a crew. They can carry cameras, sensors, and thermal imaging systems. They can be cheaper and easier to deploy in some cases. But drones do not replace everything. A manned aircraft can carry observers. It can cover larger areas. It can operate with human judgment on board. It can carry more equipment and stay useful in missions where people need to see, decide, and respond in real time. That is why the Optica still feels relevant. It was almost like a manned surveillance drone before drones became mainstream. It asked the right question too early. What if an aircraft was built mainly to observe? That question is everywhere today. The Optica saw the future. The market just was not ready. The Edgley Optica did not replace helicopters. It did not become a global success. It did not fill police hangars around the world. And it did not create the new aircraft category its designer hoped for. But it still matters. Because aviation history is not only about the aircraft that sell in huge numbers. It is also about the aircraft that ask new questions. The Optica asked one of the most interesting questions in light aviation. Could a fixed-wing aircraft do some of the observation work of a helicopter at lower cost? The answer was yes, at least in theory. It could offer visibility, slow flight, lower noise, and efficiency. But the aircraft was caught between categories. It was not a true helicopter. It was not a normal airplane. It was something in between, and that made it difficult to sell. But that is also what made it unforgettable. The Optica looked strange because it was designed honestly. The glass cockpit was for visibility. The ducted fan protected the view and reduced noise. The twin tail booms supported the rear structure. The slow flight matched the surveillance mission. Every weird feature had a reason. That is why aviation fans still love it. It was not weird for attention. It was weird because the mission demanded it. The Optica failed as a business, but not as an idea. And sometimes, that is what makes an aircraft legendary. The Edgley Optica is one of the strangest aircraft ever built. But strange does not mean foolish. Its giant glass cockpit gave the crew an incredible view. Its ducted fan helped reduce noise. Its fixed-wing layout offered efficiency. Its slow flight ability made it useful for observation. And its entire design was focused on one mission: seeing the world better from above. It was built to challenge the helicopter, not by hovering or landing vertically, but by offering a cheaper and quieter way to perform certain observation missions. For a moment, it looked like the idea might work. The aircraft flew. It was certified. It attracted real interest. And then came the setbacks, the crash, the factory fire, the financial problems, the market hesitation. And eventually, the Optica became one of aviation's great unfinished stories. But maybe that is why people still talk about it. Because the idea was never boring. It was bold. It was specific. It was strange for a reason. And decades later, in a world filled with drones, surveillance aircraft, cameras, sensors, and low-cost aerial monitoring, the Optica feels less like a failed experiment and more like a machine that saw the future too early. It was not the aircraft that replaced helicopters, but it may have predicted what aerial observation would become. A platform built not around speed, not around weapons, not around luxury, but around vision. And that is why the Edgley Optica still matters. It was the flying eyeball that tried to change aviation. The world just was not ready to look.